In this video, I'd like to go over some of the astronomical events for 2020, and I'm making this for the Central Time Zone. You might have to do a little adjustment if you do not live in the Central Time Zone. And at the end of the description here, I'll show you the resources I use to come up with this information and alert you to a website where you could freely print off this list of astronomy events for yourself, as well as some other information. So we're already recording this January 24th, so sorry for the little delay here, but some of the other interesting information that you might consider here. January 5th of 2020, Earth was closest to the Sun in its orbit. This is a regular pattern for the northern hemisphere, that the Earth is closest to the Sun in its orbit when we in the northern hemisphere have winter, and the seasons are caused by the tilt of the Earth. In the wintertime, the northern hemisphere is tilted away from the Sun, so the sunlight is somewhat diluted as it hits the ground. We don't get as much energy per square meter in the winter months for those living in the northern hemisphere. And supermoon, so-called, coming up. The moon has an elliptical orbit from our point of view around the Earth, and this is one of the months where the moon is somewhat closer to the Earth than average. The moon will not be dramatically bigger, but if you're a careful observer, you can observe that the moon has a bigger angular size on the sky. Again, this is due to its being relatively closer to us than its average distance. February 10th, Mercury stays relatively close to the Sun on the sky. Only a few days of the year when it's easily viewable, and February 10th is one of those days. Before February 9th, February 11th, you'll also be able to see Mercury, but it's to the left of the Sun on the sky. So as the Sun sets in the west, left of the Sun, Mercury will still be above the horizon, but it'll be low in the western sky. You'll need to have a clear view of the western sky after sunset, and it won't be especially bright. February 18th, there's a event where the moon is going to pass in front of Mars from the point of view of observers on the Earth. And there's a website here where you could look up the exact timing for your location. But where I live in Omaha, at 5 hours, 51 minutes, 14 seconds a.m. Central Standard Time, the moon will slide across Mars and block it for a short period of time. I think when Mars reappears, it's daylight. You won't be able to see that. This is a leap year. 2020 is divisible by 4, and there's some other rules that apply, but the basic rule of being divisible by 4 gives us a leap year. The century years, you'll have to look up the rules for that. They're not every century year, every 100 years is not actually a leap year. So the Earth requires not 365 days to go around the Sun, but 365.25. And again, this is a little bit approximate, but that's why every fourth year, roughly, is a leap year, to keep our calendar from sliding too much so that we don't have snowfall in July in Omaha. The calendar is sort of reset every fourth year by having this extra day, this leap year day, so our seasons don't slide around the months, slide through the months. March 9th, another supermoon. I don't want to miss March 8th, daylight savings time. So move your clocks ahead, spring ahead on Saturday night. Another supermoon, I've already talked about that. Saturn being close to the moon and Mars close to the moon on March 18th. You can see those times. Again, adjust if you don't live in the Central Time Zone. And then March 19th, on the sky, the Sun is crossing the celestial equator, the dividing line on the sky between the north half of the sky, north hemisphere, and the southern hemisphere. On March 19th, the sun, from our point of view, is on that celestial equator on the sky. So 12 hours of daylight for everybody on the Earth. March 24th, Venus, it's already visible now in the western sky here in January of 2020. But Venus will be at its largest angle left of the sun, so it'll be fairly high in the western sky after sunset. And April 3rd and 4th, a nice photo opportunity, Venus being near the Pleiades star cluster, that open cluster of stars in the constellation of Taurus. April 7th, another supermoon. And then April 12th, Easter. Easter moves around quite a bit on the calendar. Again, it's a little bit complicated, but Easter is a rough rule for Easter. This is not all of it, but a rough rule for Easter. It's the first Sunday after the first full moon that occurs on or after March 21st. And Easter can be as late as April 25th. So April 12th, it's not especially late this year. And Mars being near the moon, April 15th. And then a meteor shower, April 22nd/23rd, the nighttime in between April 22nd and April 23rd. There's going to be a problem this year then that the moon will be lightening up the sky quite a bit. We have a full moon near this time to deal with. May 2nd, Jupiter begins moving westward through the stars on the sky. This is due to the Earth moving around the Sun as well as Jupiter moving around the Sun. Earth is on the inside track. It moves faster around in its orbit than Jupiter does. And as we catch up with Jupiter on this inside track, from our point of view, Jupiter begins to move westward on the sky. And that will continue until August. So this is a nice amateur astronomer activity to kind of keep track of what stars Jupiter is near. Start in April, and in May you'll notice that it's changing direction. In April, Jupiter will be moving left on the sky, eastward on the sky. But starting May 2nd, it'll start to move back to the right. Another meteor shower here, but not good because the moon is going to brighten up the sky. Another opportunity to view Mercury, June 4th, left of the sun on the sky. And Saturn being close to the moon, June 8th. June 20th, the June solstice, when the sun is as far north of the celestial equator as it gets during the year. And being very far north, it rises in the northeast and sets in the northwest. Being very high on the sky gives us our fewest number of dark hours and long number of daylight hours. This in combination, the sun being above the horizon and the Earth being tilted towards the sun, in the northern hemisphere being tilted towards the sun, for June, July, August for the northern hemisphere, causes us to have warmer temperatures in the northern hemisphere. But note July 4th, now we're the farthest point from the sun for 2020. The Earth's orbit is not circular. The Earth's orbit is a little bit elongated, and consequently we're far from the sun. But again, it's the tilt of the Earth that controls the season, not the fact that we're close or far from the sun. July 5th, Jupiter being near the moon. July 14th, the sun, Earth, and Jupiter form a straight line, with the sun and Jupiter being 180 degrees apart on the sky. So this is the time when roughly the Earth is closest to Jupiter on the sky, and Jupiter consequently is bright. And Jupiter will rise when the sun sets. So Jupiter will be visible all night long. Saturn has this effect. As the Earth goes around in its orbit, there'll be a time when the Sun, Earth, and Saturn are in a straight line, with the Earth being in between the Sun and Saturn. And again, this would be a good time of viewing Saturn. Be fairly bright in the sky and a larger angular size if you're viewing through a telescope. August 12th and 13th. Again, a famous meteor shower, but again, the moon is a problem. Third quarter moon. The best time to view meteors is after midnight, as the observer at that time is on the side of the Earth that's going forward in its orbit. And we'll get any more into that, but it's the best time to view meteors is after midnight. Unfortunately, the moon is going to be in the sky and limiting the dimmest meteors that you might see. August 28th, Jupiter near the moon at sunset, and another full moon occurring. And again, September 5th, the famous retrograde motion that was important in astronomers in deducing the layout of the planets, whether the Earth was at the center or the Sun was at the center. Retrograde motion, the study of that, has a role to play. And our September 22nd, the equinox again, the Sun on the celestial equator. And then October 1st, we have a harvest moon. Due to the position of the moon's orbit in the sky, in this fall season, the moon rises not quite 50 minutes later. It's more like half hour later each night. So it's rising roughly at the same time and night to night, and giving light to people who had to work in the fields in our agricultural economy. October 1st, another time to view Mercury in the sky. And October 13th, Mars at opposition, a good time to view Mars. It'll be bright and a large angular size as you look through a telescope. Then we get to some better meteor showers, October 21st and 22nd, the Leonid meteor shower. And the moon is going to be set before midnight, so you'll be in good shape to view this meteor shower. November 1st, we have to end daylight savings time. We get to sleep an extra hour. The Leonid meteor shower, again, the moon is cooperating this year for that, and the moon won't be a problem for viewing this meteor shower. The Geminid meteor shower, December 13th, 14th, and again, if you can get to a dark location, that would be best, but the moon won't be a problem. December 14th, total solar eclipse, but the path of the dark shadow of the moon on the Earth is very narrow, 50, 70 miles, something like that wide. And this particular time, the track of that shadow crosses Chile and Argentina. December 16th, Jupiter will be near the moon. Saturn's also near the moon. That might be something to view. And during this time, we get December solstice, the shortest daylight hours of the year. But during this time, starting about the 15th, I plan to make my own note of where Jupiter and Saturn are in the sky close to each other. They'll be getting closer and closer and closer until December 21st. They're going to be extremely close together. Now, unfortunately for North America, they're going to be below the horizon when they're at their closest approach, 1/10 of a degree apart from each other. But it'll still be somewhat spectacular as to how they move close to each other and then move apart from each other on the sky after December 21st. And if you don't catch this one, then you wait till 2080 is the next time they're going to be this close together in the sky. A conjunction, where two celestial objects are close together on the sky. So here's a list of references I used to make this page. I didn't write down everything on these sources, so feel free to investigate these on your own. And again, astronomy.gpclements.com. One of the top links on this page is a link to this Word document where you can freely click on that link and download the document and print it out for yourself and anybody else you want to share it with, that's fine. The website also lists my astronomy YouTube videos, instructional videos for an introductory astronomy course, a few sample problems, and then a more extensive listing of videos on physics.gpclements.com for an introductory physics course and lots of sample problems worked out. They're all They're all listed there and kind of annotated, give you a little description of how long the video is and what the topic is. My last astronomy topic for 2020, no good lunar eclipse, no total eclipse to inform you about for 2020. So I hope you get out and view these things in the sky that are taking place, and feel free again to visit my websites and look what's there, and then watch my YouTube videos. That's great. Ask your instructor if you have any question.